Everyone. Uh, Greg did such a good job. I think he covered everything on my slides too. So I'll see if I can add anything new to new to what Greg said. I'm Krishna Muriki. I'm one of the HPC user services consultant within the group. So I'll be talking more about the user environment and what users can expect when they get onto the machine. Just to reiterate, the faculty computing allowances. Allowances can be granted to UCB faculty, not to postdocs or grad students or staff on the campus, and faculty have to be an academic career track, and this is a faculty who are working on a defined research problem and need more computing power. They can obtain a faculty computing allowance. The application procedure is very simple, as mentioned before. There is an online requirement survey, and just fill it out. And these allowances can be used either by the faculty, or the faculty can delegate his team members, like his main grad students or postdocs, to use his allowance on behalf of him. If the faculty is not the one who is doing the hands-on computing, then he can delegate. He can request for additional accounts to be created for his grad students or postdocs, and put them under this allowance and allow them use his allowance on behalf of the faculty. And there is an additional user account request form which can be filled for each account that needs to be created. We highly recommend, and it is mandatory, that your accounts are not shared. If faculty gets an account, the grad student should not be getting access to the account and using on behalf of the faculty. We can issue one other account for the grad student along with the faculty who needs to use the cluster. So make use of that. As just simple as that. And a couple more notes about the allowances. The allowances usually start around June 1st of every year. And if we do continue to accept requests throughout the year, so requests that start mid-year, they will be granted prorated allocations. And once a particular request is approved, we would be setting up a Savio cluster specific project, and the names of those projects would be like FC_project name. We would be collecting the project name from the online requirement survey. That is one of the field in there. You can choose a single word and you can specify that to us, and we will be setting up that project and adding all these user accounts under that project. And we'll be setting a scheduler allocation for the number of core hours that has been granted to this allowance. Like starting from June 1st, it would be 200K core hours. And remember that these are annual allocations, and they expire every year by May 31st the following year. And yes, please.
So, what's the purpose of having multiple projects? Does the 200,000 hours go to project, or can you break them up?
They go to the project, and every user who is under the project all of them put together collectively can use the 200K core hours. That's how it is.
So, are you promoting setting up with multiple project names for particular purposes?
So each faculty would get only one allowance. So each faculty would get only one project. Other than faculty computing allowance, a faculty can have a condo contribution, right, or some other special access. For them, they will have multiple projects. Like if you are a faculty with an allowance and also condo contribution, you will have one project which should be FC_project name, and another project corresponding to your condo contribution, which would be CO_, either the same project name or different project name, just to keep track of multiple different access mechanisms that you have and your grad students have, just for keeping track of that. Okay.
Multiple faculty can pool their allowance.
That's true. Yeah. So if 3 or 4 faculty in the same department decide that all our research problem is the same, and all like 4 of them pool, and we can have one project set up with 800K core hours, and the grad students of all the 4 faculty can be under that single project, and they can share the core hours. Like say, if two of them do not have any compute needs this year, but they might have more compute requirements next year, they can trade their allowances with other faculty, and we can do that. Yeah. And every year, we do not do auto renewal of these allowances, and we request faculty to fill the same requirement survey, or maybe a shorter form requesting their allowances to be renewed the following year. Okay. Savio access, Greg covered about this. It's a Linux cluster, so primary way to connect to this resource would be using SSH, and we have a host name, server name hpc.brc.berkeley.edu, and we do use one-time passwords. So when your account is being set up, you would be sent instructions on downloading a software program called Pledge, and you can have this program installed onto your workstations, laptops, into your smart mobile devices, iPhones, Android devices, and this software can generate one-time passwords on the fly, and you would use that one-time password when you are SSHing to the cluster. That's how the one-time passwords would work. And once you SSH, as Greg was saying, we do have multiple login nodes, or front-end nodes we call. Once you SSH from the UC network and get in, you would be randomly placed onto one of the login nodes or front-end nodes. And this is for better load distribution, such that not all users on the cluster are just on one node and doing their activities on one node. We have 4 nodes right now, and they are randomly distributed once they get in. And these are the nodes where you would do everything except 2 things. One thing, data transfers; 2, running your application actually. For staging your files, editing your files, program compilations, interaction with the job scheduler, checking on the jobs that you have already submitted, checking on the jobs that have finished, checking the outputs. All those activities you would be doing on the login nodes. Okay, and along with the existing SSH access, in future we are planning to provide 2 other ways of connecting or accessing the Savio cluster. NERSC, the Computational Center at Berkeley Lab, has a software called Newt, Nice and Easy Web Toolkit, which provides a RESTful API, a web API. We can support that within this infrastructure. Once we have that API implemented, you can develop websites and use like JavaScripting. On the back end, you can use that API and connect to the infrastructure, access the files, do the file transfers, interact with the job scheduler, do all the job management activities, and you can develop your own web portal. If you do not want to have to SSH to the cluster and do those things manually, you can, using that web API, you can have a website developed which does all those things through clicking web forms and things like that. That is one option which is coming in future. And we are also looking at supporting IPython notebooks and through Jupyter Hub integration for authentication. Those are coming in very near future. And then the data storage options, which Greg also covered this. One thing to remember, there is no local storage on any of the compute nodes. All the storage is accessed only over the network, either through an NFS protocol or Lustre protocol. And with these 2 storages, we have multiple file systems, and Greg did go into details about all those things. Home file systems, which is NFS mounted. The quotas which he was mentioning is about 10 gigabytes per user account. Each user will have their own user home directory. It is backed up, so put your important files in there, your source code, your scripts, important data. That's where all that can go here, so that it's backed up and we do not purchase anything that you put in there. And then the Scratch file system, which is a Lustre-based file system, which is about upgraded to close to 1 petabyte, no quotas, and there are no backups. Remember, this is a Scratch file system, so put something there only if you can be comfortable that it vanishes the next day. So you have to be very careful in treating that as Scratch. So if you have something very important, don't leave a copy of that only in the Scratch file system. Have a copy of it somewhere else. Currently we do not have any long-term archives storage options within the infrastructure. And as Greg mentioned, right now we're not doing any purging in scratching, but we can purge it if it becomes. Yes?
How often do you back up?
The home directories, we do it nightly, every night, and we also do hourly. Do we?
We get snapshots hourly.
We do snapshots hourly, but the backups done every night. Okay. And then the third one is the project or group space. This is not given by default to all the groups, all the projects that come online. If a particular group requests for it, we can grant this. So this is about 200 gigabytes of space. It's also NFS mounted, and it would be on this storage. And this is a group storage where if you are installing software or importing a data set which not only you but other members in your group would be using, instead of replicating a copy of it in each of your home directories or your scratch directories, you can leave one copy in the group space and everyone in your group can access it. And we can enable Unix permissions such that only your group can access, no one else can access. All that is supported through this space. Again, we do not do backups in this area, but we also do not do any purging. It's 200 gigabytes of quota per group, not per user. Okay. And then the data transfer, as Greg mentioned, yes, may remember that we do have a nice data transfer node connected to the Science DMZ. You want to use the dedicated data transfer node to do all your data transfers, and the server name is dtn.brc.berkeley.edu. And we do provide, along with providing all the traditional tools that you would use, SCP, SFTP, rsync, BBCP, all these, we also provide Globus for data transfer management. How many of you are familiar with Globus? Yeah, Globus is a really excellent tool, and we highly recommend using Globus to do all your data transfers. It's a service it's a web service by University of Chicago. You go online, you choose your source and destination, and you just drag drop files, and it will manage the transfer for you. Even if either source or destination goes offline for some time, it will auto restart the transfers, and at the end you will get an email that the transfer finished. And so it's a managed service, so that's really helpful. If you're doing a lot of data transfers, a lot of files on a regular basis, I highly recommend using Globus for that. And as you can see, writing to data transfer node, writing to Lustre Scratch file system via data transfer node goes over the InfiniBand fabric, which gives you faster transfer, much speed. Faster writes and faster I/O. And then the software support. Greg briefly mentioned about this. Also, we use environment modules, and this is a Linux system. On this Linux system, we do come with all the most commonly used packages are already available. We pick the source code of all those packages and we compile them for you. And using environment module package, you can easily access all those packages. There is a command called module, and using that command, you can browse through all the packages that we have installed and made available to you, and you can very easily say, I want to use this particular software with this particular version. And you can specify all that using this module command, and it would make that package available in your environment. You would just do something called module space load space package name, and it would load that module in your environment, and you can use that. Just to give a taste of what kind of things we have supported, this is a very short list. We have a much comprehensive list on the resource. Just because of the space on the slide, I just listed only few of the top ones. Tools like Octave is an open source equivalent of MATLAB. Yes, Chris?
Is the 80-core license, is that 80 cores collectively across all users or 80 cores per user?
80 cores collectively across all users. So up to 4 nodes you can run MATLAB with MDCS on up to 4 nodes. That's all.
So you're locked out if somebody else would be using it?
Yes, that's all. So all the open source tools, there are quite a bit of them. GNU-plot, a lot of visualization tools, compression algorithms, source control, revision control tools, debugging tools, and languages, different languages that we support. Java, we do have multiple versions of Python, and are also available. And we also maintain a lot of packages, Python packages and R packages by default on the machine. And along with the open source, we have, Greg mentioned that we all purchased Intel compiler suite, and other one which we purchased is MATLAB. Campus has a site license for MATLAB. We use that but the campus site license provides only serial computing and parallel computing toolbox. With parallel computing toolbox, you can scale within a node. Like nodes here have 20 cores, so you can run up to 20 cores only. But if you want to scale above a node, run MATLAB parallelly across 2 nodes or more, you need to have a special license called MDCS, MATLAB Distributed Computing Services. And we have a license for that with 80 cores, so you can run on up to 4 nodes. And this is all this package list that we provide. Along with that, users come with their own requirements, their own list of packages that they want to run. If that is outside the list of packages that we already provide, then we recommend that user try to build the application by themselves using from the source code. And we recommend that if you want to share it with other members in your group, install it into your group storage space instead of your home directory space, such that once installed, other members in the group can use it. And if you need help with that, we are available. Savio consultants are available to answer your questions and help you with the installation of your own specific application or package. Any questions? Next important topic we want to go into detail is job scheduler. How to get your applications running on the cluster, how to get your jobs going. As I will quickly cover this table first. We have multiple types of nodes available on the cluster. Greg mentioned about these 2, and he mentioned this is upcoming, but I already added this here in the table. The standard nodes are available as with the partition name Savio, and there are about 160. I think we have more than that right now. This number might be slightly outdated. 20 cores per node, 64 gigabytes of memory. Remember, no local storage. All the storage is over the network. And the big memory nodes, we have about 4 of them, not a lot, but with half terabytes of memory per node, and again, no local storage. And then the third category, which we already have purchased, and I think we are in the process of putting them online, is they are the serial HTC type of nodes, where we'll be having altogether 12 nodes to start with. They will have only 12 cores per node and 128 gigabytes of memory, and they also come with local PCI flash. If you have applications like SAS, which does a lot of I/O, and doing that I/O over the network to Lustre or NFS file systems, if that is not fast enough, then yes, you can use these nodes. So when you submit jobs to run an application on the Savio cluster, this is the first thing you want to do. Choose which node you want to run your job on. Based upon the node, you would specify the partition as one of these values. Okay, I want to run my job on the big memory node, so partition is equals to Savio _ bigmem, and then one of those 4 nodes is where your job will end up running. You need to be familiar with that, and then after that, the scheduler configuration that we have on the cluster provides 2 quality of services on like how the turnaround time and what kind of job you are trying to run. The 2 quality of services that we currently support are debug and normal. A debug job is something where you are just testing if your application would start running, if you have all your input parameters, output parameters already all set properly. If you want to quickly test if my application would even launch, would start running, you might want to use this. That would give you a quick turnaround, would guarantee you a quick turnaround. The maximum time you can say that I want to run job with this quality of service is 30 minutes, you don't even need 30 minutes when you're doing testing, right? So you can just say 10 minutes, or you can say 10 minutes or 15 minutes is what I want to run this job as, and up to maximum of 4 nodes. So 4 times 20, 80 cores is what you can request for. But in most cases, we do not see users using this particular quality of service needing all the 4 nodes. They will be just running on 1 node. And then the other standard one is the normal quality of service. In this normal quality of service, we allow users to submit jobs saying that they want to run maximum up to 3 days, 72 hours. This is the max we allow right now. And the maximum number of nodes you can run, you can request for a single job is 24. Yes?
Is that wall time or CPU time?
This is the wall time, exactly. Yeah. You can have multiple jobs submitted to the queue, but per job, the maximum number of nodes is 24. And right now, the way you interact with the scheduler is through command line tools and utilities. Slurm is the name of the scheduler that we use, and Slurm comes with a lot of command line tools and utilities, and you would use those to say, okay, I want to run this job on this partition with this quality of service and this wall clock time, this many number of nodes, and this is my application that I want to run, and these are the input parameters, output parameters. There are a lot of command line tools using which you can specify all of that and submit your jobs to the queues. And in future, we are looking, as I mentioned, the Newt RESTful API does provide URLs, web URLs for job management also through Slurm. So once we have this available, if you want to develop a website to do all of this Newt REST API would allow you to do that. And we would be supporting IPython notebooks along with Jupyter. So if you just want to launch a Python job through IPython instead of interacting with Slurm directly, then yeah, we would be supporting that also in future. Okay. And finally, about job accounting. So a few important points to remember is in the excuse me, in these 2 partitions, like the general nodes, 20 core 64 gig nodes, and the big mem nodes, 20 cores, half a terabyte nodes. The nodes are jobs gain exclusive access to the assigned compute nodes. So if you are running a job, then you would be using a minimum of 1 node. That means you are using all the 20 cores on that node. Let's say if you're running for 5 hours, that means your job would cost about 100 core hours. Whereas in the Savio HTC partition, it's not, the multiplier would not be 20, it would be the number of cores that you would specify, because in this partition, the nodes are not assigned exclusively. Only the number of cores that you say that I want, that is there would be a default value. If you do not specify in the number of cores, then maybe we'll assign the default number of cores to you. But in this, for the last partition, Savio HTC partition, this multiplier will not be 12, it would be the number you specify.
And interesting to see what happens, but I would suspect that those HTC nodes are going to get a lot of use, because there's a fair number of people who say, I want 4 cores, I don't want to pay for 20 cores for an hour.
Sure, yeah. Yeah, that is this is what we heard from multiple users, and that's the reason we support it. You have a question?
No, I was seconding.
Oh, okay. Next, and finally, how to get additional help. We have a lot of information online. There is a user guide at this link, and I think there might be these web links on the handouts that have been given to you, and all the new user information, all the things that a new user have to do with account setup, pledge software setup, all that is also available here. And the help desk, the details about the help desk, this is where how you can reach us, BRC-HPC-help, and emails to this email address go into a ticketing system. So, and the tickets in the ticketing system has visibility. Like a lot of people in IT will have visibility. So make sure you put what you want to put in the ticketing in the emails you send to there. And the support hours are Monday to Friday, 9 to 5 p.m. and best effort in non-working hours. And I think that's about it. Yes.
So suppose you don't want to use some software that requires a FlexLM license, and I'm running a FlexLM license server. I guess that could have some firewall implications, punching a hole to get the license.
So we do support commercial license, so we have infrastructure for hosting FlexLM licenses. So if you want us to host, we can host it. If not, if you already have a FlexLM license server, then the way this firewall works is we have a tighter restrictions on incoming network. But if your application is running on a particular compute node and it needs to check out a license from a FlexLM server running here on your laboratory, the application can go out and contact any server out there without any needed modifications to this BRC firewall. The only thing that you need to make sure is this box where your FlexLM license is hosted, it does not have any firewall restricting connections from outside. If you do have a firewall, yes, you need to make punch holes in there such that the connections from we can give you the IP address range which you want to punch the holes, and we can support that. Yes. Or if you just want us to host the license for you, we can do that also. Any other questions?
So we're going to hang out